Here are some more examples for us to practice naming alkenes and alkynes. And we have up here for a reference the rules for naming alkenes and alkynes that we can refer to if we need to as we are practicing. Our step 1 is to find the longest chain of carbon atoms that contains the double bond, in this case because it's an alkene. And now we are going to number that chain of carbons starting at the end closest to the double bond. We are then going to locate the double bond using the first carbon of the double bond as our location. So the double bond is in between carbons 1 and 2. We are going to use the first carbon of the double bond as its location. 1. This is a 4-carbon chain. If you refer back to your table of alkanes, I want to say it's table 12.1, it might be 12.2. A 4-carbon chain is butane, but because this is an alkene, we drop the ane and replace it with ene. So this is 1-butene. Here's another example. First we find the longest carbon chain, and then we number, starting at the end, closest to the double bond. So this time we're numbering from right to left. We locate the position of the double bond using the first carbon of the double bond. So here's our double bond. It is in between carbons 2 and 3. The first carbon that participates in the double bond is carbon 2. So that is its location. This is a 5-carbon chain. Take a look back at that table of alkanes. A 5-carbon chain is pentane, but this is an alkene. Drop the ane. This is pentene. Next example. Find the longest carbon chain, number, starting at the end, closest to the triple bond. It's a little bit harder to see all the carbon atoms in an alkyne because of the way the line segments are lined straight up instead of being angled, but there they all are. Locate the position of the triple bond using the first carbon of the triple bond. Triple bond is in between 2 and 3, so its location is 2. This is a 6-carbon chain. If it was an alkane, it would be hexane, but it's an alkyne, an alkyne, so this is hexyne, 2-hexyne. Next example. Find the longest carbon chain, number, giving the triple bond the smallest possible number. Remember, when we have a cyclic, if we have to number the cyclic, we get to choose which carbon is carbon number 1. So we're going to choose to use one of the triple bonded carbons to be our carbon number 1. Now we have to think, how should we go about numbering this ring? Should we number clockwise like this around the ring? Or should we go the other way, counterclockwise? When you are numbering a cyclic alkane or a cyclic alkene, you are always going to want to start the double bond or triple bond at carbon number 1, and then the next carbon, carbon number 2, needs to be its partner in the double or triple bond. So the double or triple bond always needs to span 1 to 2 when we're doing a cyclic. So location of the triple bond is 1. If this was an alkane, it would be cyclo, 6 carbons is hexane, but this has a triple bond in it, so it is cyclohexyne. Now we're ready for some more complicated examples. We're going to find the longest carbon chain and number, starting at the end, closest to the double bond. This molecule has another substituent on it. It has the chlorine on carbon number 5. You might be wondering if the rules change for numbering the carbon chain when you have a chlorine present? And the answer to that is no. Even if you have other substituents present, you are always going to start numbering closest to the double bond or the triple bond. Our goal is to give that double or triple bond the smallest possible number. When we have other substituents on the molecule, we will, like you learned with alkanes, you will start by locating and naming those substituents in alphabetical order. So our first job with this molecule is to locate and name the chlorine that is on carbon number 5. We say 5 because that's its location, chloro, which is the way that we name a chlorine, bromo for bromine, iodo for iodine. Then, once all of our substituents are named, then we move on to naming the alkane. The location of the double bond, it starts at carbon number 1, and the parent chain, pentane, except for this is an alkene, so it is pentene. 5-chloro, 1-pentene. Let's look at some more examples. Find the longest carbon chain. Number so that you give the triple bond the smallest possible number. The triple bond is closer to the left side than to the right side. So 1, 2, 3, 4, 5, left to right. Remember, it's really easy to not see all of the carbons in a triple bond, so let's highlight them. Our substituents in this molecule, we have a substituent on carbon number 4. So let's locate that substituent. It's on carbon number 4. And let's name it. That's a 1-carbon substituent, so it is named methyl. The names of the substituents, I believe, is in table 12.2. 4-methyl. Now locate the triple bond. It starts at carbon number 2. The parent chain is pentane, but this is alkyne, so it is pentine. 4-methyl 2-pentine. We've got 2 more examples. Here's a cyclic. We want to number to give the alkene the littlest possible number. So that means we either want to make this carbon number 1 or this carbon number 1, one or the other. We're going to have to think a little bit about this one. So let's imagine we make this one carbon number 1. That means this guy is carbon number 2. And then we would continue around the ring 3, 4, 5, like that. That's one option. Our other option, I'm going to do this in a different color. Our other option would be to call the alkene carbon on the right-hand side, we'll call that one number 1, and its buddy is going to be carbon number 2. And then we're going to go 3, 4, 5 around the ring like that. So those are 2 options that we have. We definitely always have to make the alkene carbons number 1 and number 2. We do not have a choice in the matter there. When we have a situation like this where either one could be 1 or 2, and whichever one we choose will affect the numbering and the location of our substituent, then we're going to look at that substituent, and our goal is to give it the littlest number possible. If we can see here that our substituent, when we number this molecule, our substituent is either going to get the number 3 or the number 5, depending on which way we go. And it would be better for us to give it the number 3 because that's a smaller number. We want to give that substituent a small number. So I'm going to erase all of these red numbers, and we're going to stick with the blue numbering because the blue numbering gives our methyl the littlest possible number. So once we've got that figured out, locate the substituent. It's 3. Give it a name. Its name is methyl. Name the parent chain. This is cyclo, 5 carbons is pentane, but drop the ane and call it ene because of the double bond. We've got one more example. Our longest carbon chain is a 4-membered ring. We are going to number the carbon chain. We know that we want one of the alkene carbons to be number 1 and the other one to be number 2, and then we go around the ring. Let's consider the other way around. Let's call this guy number 1 and this guy number 2 and go around the ring. And we'll ask ourselves, is there a difference here with the red numbers and the blue numbers in terms of how we would number bromine? If we use the blue numbers, bromine will be on 1 and on 2. If we use the red numbers, bromine will be on 1 and on 2. So in this case, it's like a super tie. It doesn't matter how we do it. We're going to get the same numbers either way. So I'm just going to go with the blue numbers. Locate our substituents. We have a bromine on number 1 and a bromine on number 2. Remember, when we have two identical substituents, we put both of their numbers first, 1, 2, and we say di-bromo, 1,2-dibromo. This is a cyclo, bute. Oh, you know what? I forgot the location of the double bond. 1,2-dibromo, 1-cyclobutene.